Lance, you ready? Yeah. Cool. Welcome to Hack Sunday. I'm pretty sure I know everyone here in the room. Thanks for joining us. Today we have Gaurav here. We're recording too, Trick? Beautiful. So I will let Gaurav introduce himself, but basically on our chat there, they were talking about vector databases, and Stanley's tried to explain vector databases to me, and I said, Gaurav, I have no idea what you're talking about, so will you please put together a presentation for us to teach me, because I still don't get what these are. So Gaurav, how about a quick about yourself for anybody who doesn't know here?
Yeah, so I'm just a senior software engineer working at an insurance tech company. I have had some chance to research into computer vision algorithms, and lately I have been into generative AI, and that's where I started dabbling into vector databases. And I also got a chance to write a chapter on vector databases in one of the AI playbook. So that's what that's what triggered Jerry to invite me. Thank you, Jerry, to give this talk. And let's get into it.
Beautiful.
So let's start with what is database. And I don't want to make this talk like somewhere I'm just talking, giving a lecture, college lecture. So I would like this talk to be like as interactive as possible.
And we do have two wireless microphones right there.
Some mics right here. Anyone with questions? Pass them around.
I have a question from the group chat. They'd like to know where they can live stream this presentation.
It's not live streamed.
For
who
the
is
future.
asking? Wait, who is asking? I want to know.
Josh,
Which Josh?
show me your
Oh, show me. Oh, cool. Huh. Maybe next time we will.
Tell me stuff.
Yeah.
Cool. So as we all know, database is a structured collection of information, and it's like a software that people use for information storage and retrieval, right? But over the time, these databases started evolving into different types, and we now have different types of databases. So now we have document databases, we have relational databases. These are the most commonly used databases everywhere. Then we started into analytical databases, which is like analysis that Stanley does on his genomics and everything. Then we have these graph databases, which are really good for relational for storing relationships. And Facebook is the greatest example for use of graph databases. And then people started thinking, why only save databases in row-wise, right? Can we store them and retrieve them in column-wise? So we started with columnar databases. And then finally, as everything is a key value pair, so a key connects to a value, and there we have like key value pair databases.
Before you go too far with that,
Sure.
So, again, maybe I'm the dumbest person in the room and I'll ask some rudimentary questions here, but I am already getting lost in this. So you just said that Facebook is a graph database?
Facebook uses graph database to store the relationships that we have with our friends.
How many people knew that? Okay, all right, so I'm not alone over here, but all right.
And if you don't mind me just jumping in for 1 second.
Sure.
Please.
I love to think about the contrast between relational or tabular databases and graph databases, because I feel like we all naturally think in graphs. Like I see Gaurav, I know we're connected by a friendship, and the same with Jerry. And you almost think that there's a spider web of relationships that encodes the social structure of this community here. And that's what our brains do, is they're like, set to think about the relationships and the relationships between people. And so I always have to feel like it's almost like we contort ourselves a little bit to think in tables.
Yeah, yeah. So and again, I know Stanley, you would be dabbing into graph databases pretty soon. So that's a.
I am like tickled pink because I'm actually pushing a petabyte of data into a graph database starting Monday. So Jerry,
Awesome.
I'm so excited that this talk is happening today, bro.
Dope. Now, okay, does everyone else already know what analytical databases are? Because that's also a new one to me.
I do not.
So analytical databases are, for example, Amazon Redshift. Now you have relational databases.
mic up
Oh,
there.
sorry. Yeah, first time. So relational databases are usually you can just store a limited amount of data. Now, if you want to do some, yeah, hello, yeah. So if you want to do some historical analysis, for example, on stock market, how was the stock market in 1930s? So you would like to store all the transactions into an analytical database so that it can predict the patterns that are happening. So, and again, it's very hard to do that in a row-wise. Like if each row is stored in a relational database, it would take months to process your query. But when you store it like in an analytical database which uses a columnar storage, it becomes very easy and it's efficient in running those analytical type of queries.
I think I see a possible follow-up presentation coming.
Yeah, like every topic is a presentation in itself, and I'm just introducing these things to get further.
Okay,
Yeah,
I'll let you get to vector ones. I won't keep holding you up because I already got tons of questions.
What we might say though is that each of these databases you might think of it as they have a certain type of question that they exist to help answer.
Right.
And
like
then
And we'll dab into like what are the use cases of these databases as well in our upcoming slides. Yes, I do have a question over there.
I was going to say, one of the other benefits of OLAP cubes are that you can kind of pre-process the data, right? So that you can get like daily, weekly, monthly, annual summaries for like sales quarters. So if that information exists for each individual order in like a sales data warehouse, you can pre-calculate those on some frequency so that when you're querying it, it just happens instantly. So it also empowers things like ad hoc BI, where like if you want to like slice and dice data in different ways, you're not waiting for like the relational data warehouse to constantly sum up average, min, max, and run all those aggregate queries across the row level data.
Yeah. So now we talked about like mostly different types of databases. So now databases can be categorized into 3 categories: SQL, which are like relational databases; NoSQL, which are these column-based key value, graph, document; and there is something called as object databases as well. So like, I don't know, many people might know. So for column databases, the good examples would be Amazon Redshift, which you use for business analytical data, business intelligence; Cassandra, MariaDB; and then for key value pairs, there are Redis, Memcache, Couchbase. For document databases, you can think about MongoDB, Elasticsearch, DynamoDB. And for object databases, we have our pretty old friend, MS Access. And ObjectDB is a new one, that's a Java-based one. And then for graph databases, I didn't find many examples, but Amazon is coming with a new database called Neptune.
Neo4j, bro.
And Neo4j.
Sorry, forgive
me. Yeah, sure. And Neo4j. So
would also toss out Janus Graph is the kind of typical open source solution, but Neo4j is just so good. That's what I'm using.
Apache.
One thing though, there's a bit of a pet peeve here. So NoSQL started off being not SQL, as in saying it's not a SQL database.
Right.
Now conventionally it should be, and it is not only SQL. Because SQL
Get that mic in your mouth for me. Look. Oh, that's not on?
SQL is a language dialog.
Oh, wait.
And you can actually use the SQL language to query databases that are traditionally non-SQL, such as a graph database. So, and where that comes into play is FQL, which is Facebook Query Language, which is a query-like language that is used on graphs. Many other databases also have a SQL-like language because it's great. SQL is useful. So.
Did you get it on? Thank you.
Oh, well, yeah.
Yeah, thank you, Mike. So as I said, like we'll go through different use cases. So these are like some of the use cases. Relational database, you basically use it for payment system, booking system, even storing your daily transactions. Then as a friend over here said, like column storage databases are used for business intelligence. Then you have object store, which stores like files, audios, and pictures. Then graph databases, as Stanley said, like it is used for social relations and anti-money laundering. That's a nice use case for it. Then time series database, you have like stock market data, trading platform, stock exchange, and in-memory store is like cache or like flash sale kind of database usage. Now let's jump into vector database. So what is vector database? So I would like to think now we thought databases to be rows, to be columns, to be graph, and now someone said, let's think about vector this data storage in terms of like 3D space. So each data is a point in 3D space. So that's the crux of a vector database. So basically, vector databases stores the data as mathematical representations. And these points can be termed as vector embeddings. Basically, so as you can see in this example, all the animals, wolf, dog, cat, you can cluster them into a certain space. And the fruits, which are apple, banana, grapes, whatever, they are clustered into certain space. And then you can make a semantic relationship between those points and saying that these samples belong to this category. Yes?
Yeah, are vector databases traditionally limited to only 3 dimensions?
No, it's just it's just a representation, a way of representing the logical point of it. They could be n dimension, right? So you can have your data in n dimensions, but just for the comprehension of the human mind, since we live in 3D space and we understand 3D space really well, that's how it is represented.
But thankfully, the mathematics of geometry work in whatever dimensions, so we can do things like take cosines and apply other kinds of mathematics
And
arbitrarily.
That's exactly. Actually, that's the next slide. Next slide. But let's dive into how do these vector database actually work? Like how are we using this for querying, for using that as a traditional database, which is like information retrieval and storage. So as I said, vector databases do not store your data as is. They store the representation of that data. They store the point location in the 3D. Let me correct myself over there, not say 3D, but n-dimensional space in the computer. So that's called vector representation. And then they use something called as finding nearest neighbor. And we'll go through those algorithms in the later part of the presentation. And then even your query is converted into a vector representation. And then we try to do a match. And that's what the result would come out. Yes.
Not necessarily jumping ahead, but just
Sure.
seeing the correlation between that and machine learning, where you take your data and remap it into some sort of vector that you're actually learning over,
Right.
training over. Okay.
Yeah.
It's kind of interesting. I've worked on graph data-driven technologies for quite a while. I think when I started, it was estimated that about 1% of the world's databases were of graph type. And throughout my whole career, we've been kind of watching that steadily grow. And it was predicted, but by the end of the decade, we might be up to 15 or 20% of all the databases in the world would be graph databases. It's also kind of fun to remember that if you think of the market of all databases in the world, like as an economy of itself, we're talking about a big country. Like
Right.
we're talking about one of the most important economically impactful technologies, and it was already going through this huge change where we were storing this social data in graphs. It was already a major shift in the industry. LLMs are putting that on steroids, and I'm sure that'll come up in the talk, but it's sort of like everyone's going to be learning about graph databases and talking about it within the next year. It's kind of amazing. It was actually leaked in a talk a couple months ago that's how OpenAI is fine-tuning ChatGPT, as they have a big graph database.
Right. So let's get into a little bit of mathematics. So now you say you have this n-dimensional grid, and now on this grid you need to find two points and their distance, because we want to find their nearest neighbor, right? So these are some of the techniques that computer scientists are using. So for example, dot product, it's a metric that measures the similarity between two vectors by evaluating their sum of the coordinate points, right? As you can see over here. The cosine distance is the similarity between the two vectors by assessing the cosine angle between them and comparing with their magnitudes. Then this is the most famous Euclidean square. We all know that we can identify the distance between 2 points with this formula. And I like to think Manhattan, just like in Manhattan, New York, everything is a grid. And to get from point A to point B, you cannot make a diagonal. You cannot take a diagonal route. So that's how the Manhattan distances are.
Also known as a taxi cab.
Yeah.
The taxi cab metric, because you can only go up, down, left, right. There's no.
Yep.
Gaurav, do you have a man, woman, king, queen slide in there? Or?
No, I don't have that.
Okay, no problem.
If you want to go ahead and give us some more context on that. That would be great.
100%. Real quick, and forgive me, it's just that I feel like seeing the words floating around in the space is very compelling. I almost remember that we have an expression, reaching for a word. You know, when you're trying to remember a word and you can feel that it's floating out there somewhere. I think our brains use geometric embeddings of words to help us keep track of what we're saying.
Right.
But then one of the things that's really interesting about this is the way that the words relate to each other geometrically ends up reflecting their linguistic meaning. So for example, if a word differs from another word by gender, like say man versus woman, or king versus queen, the distance between those two words will always be the same. And so in a sense, like when you embed our language in a geometric space like that, the things our language says show up in the geometry of the space. So for example, all of our language is really split up by gender. And you can see that based on where the different words float in the space. It's really kind of an incredible thing.
Yeah, awesome.
Love it.
So next, what sort of searches can we do on vector databases? So these searches can be converted into two different types. One is like traditional search. This is like the SQL that you use, right? And then you can see over here you are looking for like cat, like dog, and it's like you are searching for that specific keyword in your database. Whereas in semantic search, as Stanley explained, it's looking for the overall geometry and trying to see where that concept, that context lies in the 3D space, and tries to give you that particular answer.
Do you think we could make a better language for searching this? Because on the right, that's just a bit of code, and then on the left, you have a language, a formal language to query it. Do you think we can do that?
Yeah. So people are trying to make it English-like, and I think that's how like programming languages are developed, right? First you had assembly, where everything was machine instruction given. And then we started with English-like language, like COBOL, BASIC, and then we came to C, C++, Java, and now Python is just like writing English language, right?
But a lot of these semantic search primitives are also finding their way.
Microphone, please.
Thanks, sorry. A lot of these semantic search primitives are also finding their way into traditionally relational databases. Like Postgres has an extension called PG Vector, and there's 2 or 3 other extensions that are coming out at this point that basically do the query on the right, but inside a SQL. So
That's exactly beautiful. So there's a need for that. That's awesome.
Are you saying that it will take the semantic search and then create an SQL search based off that?
yeah, so with PG Vector, it allows you to have additional functions inside your select statements and inside your where conditions. So you're able to do basically like a multi-factor search. So if you wanted to like search all of a single user's preferences, you'd be able to use traditional SQL to filter on user ID equals 1, 2, 3, 4.
We would be doing that today as part of our demo.
Cool.
So we would be searching for some images of like famous celebrities, and you would be searching it based on their file, but it will give you the results based on their features, based on their facial features. So we would be using a facial recognition basically as part of our demo.
Cool.
And it would be a SQL-like query that you will run, but you would get an image as the result.
Grain of salt, because I'm a big Postgres guy, but used pgvect in production recently, and it was very, very nice.
Awesome.
I also have a quick proposal. I think when talking to normies who don't understand AI, replace semantic search with like vibe search, We're just searching for that general vibe.
That is totally true, 100%. Another thing to mention too is just I feel like the specter of LLMs hang over all of this.
Right.
I was working with a 1,000-row data set called Spider that can train any open source LLM to convert from text to SQL queries. And it's like 99.5% accurate. It's very impressive with almost any open source LLM.
Wow. Yeah, so without any further ado, let's jump into the first one, the first demo.
Jerry, is this on the website? Or?
Yeah.
Do you want to share this on the Telegram or?
Yeah, I will do that. So that's there.
Oh, we could technically stream on the Telegram in the future. I kind of wanted to test that.
Yeah, the screen is a little washed out. I think it's mostly from the skylight, but do you think maybe, or do we have these for?
I can turn the spotlights on a little.
So in this particular demo, what we will do, we'll try to create a vector store from scratch. And what we would be doing, we'll be doing some semantic search. We'll be getting the embeddings from OpenAI, and that's why I won't be sharing my OpenAI API token with you guys. And we would do some metadata filtering. So as part of it, you can download like any sample documents. Over here, I've just downloaded this archive.
And you put the link to this in the Telegram?
Yeah, yeah.
Okay, cool. So anyone that wants to follow along, just jump on the Telegram. The link's in there.
Yeah, the link is already on the Telegram, and I want you guys to run through it with me. So then we'll do some Python installations, dependencies, and then finally we'll able to. Yeah, of course. This is loading the PDF data, and then we'll parse it into nodes. And here's the cool thing where we'll get the embeddings from OpenAI. Since this is a text search, we'll use the existing embedding. We don't need to go through creation of embeddings as part of this demo today. Yeah, over here you guys will put your OpenAPI key.
Embeddings are the vector representation of each
Yes.
token?
Yes. Embeddings are the vector representation of the data itself. So OpenAI was working on this text search for many years, and they created all this context for English language. Basically, they have created a representation of an n-dimensional space for English language, and that's what we call as vector embeddings for English language.
And so they use that base embeddings for GPT?
Yes.
The same embeddings no matter.
So it's, again, the embeddings are trained on different data, right? So GPT is trained on a different set of data. What we would be using today is TextAda 002 embeddings.
When it says their Llama Hub, is that part of like Ollama? keep saying it says llama. I think that's the only one that doesn't say it. Every other one did. If you go up or down, either of them will say it.
Okay. Where?
Llama 2 is a popular base model.
Yeah, that.
And are you generating the embeddings with OpenAI?
I'm just using their embeddings. I'm not generating anything.
Oh, wow. Very cool.
Yeah. So I'm just
Guys,
using
I'm sorry. You're going to have to explain that one. What are embeddings and why are we using
Embeddings
the...
is where the words get to float in the space.
Okay.
You
Right.
create the embeddings of the word in the space. They're embedded in the space.
So
And you said you're using OpenAI, so they already have embeddings that we can use?
yes. So
Okay.
so
You
what,
lost me.
so when you think about this model, right, LLM, basically what you are looking at is the embedding, is the vector representation of the context. Say suppose in this case it's the English language. So you know this is noun, this is adverb, this is an adjective, and you make sense of it, right, as a human. So similarly, these models were trained, and when you train them, they create the data representation, which is like the vector representation. As Stanley explained, these are nothing but points which are floating in space, right? And then when you start like doing the query, what the mathematics behind it is, like based on your query, it tries to find what's the nearest point, what's the nearest word that relates to this thing, and that's what the semantic search is all about.
The nearest thing that relates to that word in general or in terms of your search?
In terms of your search.
In terms of search. Okay, so
that's what they call
is it
context.
rearranging this database like live? Or it's just calculating, I
It's
guess.
just calculating
going
at
through
that
it.
point. It's not rearranging.
I like the picture of
The
rearranging. it.
rearranging happens when you train or when you do fine tuning. That's when the rearranging.
At the same time, though, the process of creating the embeddings does have some things like this, where it's sort of like it tries to fit some of the words in, then it measures how close those are to being
Right.
efficient, and then it puts new words in, and so it is an AI process to even generate the embeddings, though.
Right.
All right, does everybody understand that?
It's like a game, basically, right?
You don't give them the king and queen analogy. It's really
Yeah.
helps a lot.
I wonder, is it possible we
Can
can just do a quick Google image search? Because this is actually the canonical image.
You want to search and pop it on the Telegram, and then he'll just pull it up.
All right. So while you're pulling that up, I'll try with just words. So, you know, we as humans, we think of concepts in who knows how many dimensions, right? So like a human can be any number of traits. They can be a friend, they can be an enemy, they can be royalty, they can be a criminal, they can be tall, they can be alive, they can be dead, like hundreds of different dimensions that we represent in our minds for a human. A plant is also, you know, potentially a living creature, right? A rug is none of that, right? So every single thing that we learn about, we have all these weird attributes in our mind. So vector embeddings are a way for computers to try to represent up to however many dimensions are trained for that model. So for example, OpenAI's vector embeddings, I believe, have 1,536 dimensions.
Right.
With the text ADA, I believe it's 768 dimensions. And every single one of these dimensions is a value between -1 and 1. It's a floating point value. So in order to generate an embedding function, you take some corpus of text, for example, all of Wikipedia, or like every news article that's ever been published. And what you do is you kind of walk through each of those bodies of text, and you try to like remove one of the words in a phrase. And then you try and guess what is that word in that phrase. And the better you can guess what word fits into that phrase, the better you can train how these 768 floating point numbers kind of relate to each other in this space. So if there are things that could possibly fit in, like, my favorite animal is a cat, dog, right? Almost no one says giraffe. right? So giraffe is going to be farther away from cat and dog than dog is from cat or cat is from dog.
Right.
But you do that for every single phrase across this corpus, like every single phrase in Wikipedia, every single comment thread in Reddit. And this is how you can have these various different ways to model how humans represent different topics. So the canonical example of king and queen.
If you want to, sorry, I don't have Telegram on my machine.
Yeah, so the canonical example of king and queen is that you can use the representation of king as a mathematical vector, which is these 768 numbers. You can subtract out the vector for man, and then add in the vector for woman. And these are just really simple mathematical operations, subtraction, addition. And then you look inside this multidimensional space, and that result is going to be the closest to the term queen, because you subtracted the essence of a man, you added the essence of a woman from king, and then you search in this space of whatever millions of words exist in this database, and the closest one you're going to find is queen.
Yeah.
So yeah, woman plus royalty equals queen. We get to do algebra with words, and hopefully we'll just get this picture up that'll just kind of hopefully make it a little bit more concrete. But I just feel like it's so fun because there's so many things about the language we speak we're not consciously aware of, like the way that words have different resonances with different genders or different topics. It's just really amazing because these things make all that quantitatively explicit.
There you go. It's on Telegram. Cool.
And forgive me for wanting to just get this up there real quick, Gaurav. I just remember the first time I saw this, it was one of those big head exploding moments for me as a student.
Yeah, and I think to get back to the original answer, there's a difference between an embedding and an embedding function. So an embedding function can take something like a word or a sentence or an image and then return that embedding. So when we say that OpenAI has all these embeddings, sure, but really what you're providing them is you're providing them some input, then they vectorize it for you and they return the vector embedding, which is this big group of numbers for whatever you're giving them. So you give them a sentence, they return a sentence vector. You give them a word, they could potentially return a word vector. You give them an image, they could return an image vector. But that function is, I believe, proprietary to them. But there are open source versions of these that you can use for free, that you can basically chunk up whatever your own documents are and get a set of vectors just by using the compute on your MacBook.
I did also like the example you used was people and their pets, because on our Twitter Spaces we talked about artists and how they have the strangest pets. So now I'm thinking, okay, well maybe if they're an artist, maybe they would be closer to the giraffe.
Nice.
Stanley, did you want to tell us about this?
Oh yeah, well, okay, so this is just an expression of what we're talking about. So, again, the idea is we want words to exist in the space so that their geometric relationship, like how they exist near each other, reflects the linguistic information about them. So again, on the left there, you can see the male-female difference. So we have a man and woman up there, and then we have king and queen down there. And so this vector that goes down into the left that connects man and king, and this one that goes from woman to queen, in a sense, that dimension, that direction encodes the concept of gender as it pertains to the language. Mm-hmm. Similarly, in the middle there, you can see verb tense becomes a dimension, right? So walked relates to walking, swim relates to swimming. Every verb would be connected to its tense through that same direction. Similarly, on the right there, the relationship between a country and its capital is structured right there. So again, it's just really interesting because it's like, it doesn't need to be told this. It learns this by looking through all of the text and seeing that there is this pattern between when man occurs, when king occurs, when women occurs, when queen occurs. So it's just incredibly cool. It's like just, taking these concepts that we learn from our language and again, making them quantitatively explicit.
I also like how swimming and walking are slightly further away than walked and swam. So it's blowing my mind. It's like, well, are they that somehow different than the past tense?
And the answer is like probably yes. Like there are these little differences, and it's not perfect, but then you are able to do computation with it, and it's quite fun.
Yeah, and explicitly on the capitals one, it is about whatever's in that body of text that it was trained on. So when I ran these when I was playing with PG Vector for Postgres, Beijing and Shanghai were like almost like equally relevant to each other. So even though it could get like the capital of the U.S., the capital of France, the capital of Canada, it would sometimes say Shanghai instead of Beijing for China.
Right.
So it's not like it knows that you're looking for capital. It just says like this is something that is like semantically similar with whatever mathematical operation you run, which means that it's not like a foolproof knowledge graph.
Right.
It is like something that helps find things that are potentially relevant, but it might be relevant in a dimension that you're not expecting.
Yeah, and that's what I also said like in my LinkedIn post is like these are all probabilistic algorithm. There is a probability that Shanghai is a capital of China. We know as a fact it's not, it's Beijing. But for the computer, since those cities are very similar in economically, their population and stuff like that, so it can think that it is one of the capitals.
And 100% it depends on the data that you're using to train. I once had a role where I generated a lot of vector embeddings for Google in many different areas. And so actually the degree to which gender existed as a dimension is one of the first things we checked with a new series of embeddings. And if we were using social data, it would always be there. But sometimes we would be creating embeddings from like medical documents or scientific papers, and then they would have very different things captured by the model. So it's just an incredible tool, though. And as a person who had like linguistic training in school, it's just amazing what, the questions we used to ask ourselves just over a beer in musing that we can now answer kind of explicitly.
So as part of this demo, basically what we have done, we have used this embedding and used like on that particular PDF document, and finally we were able to ask a query string saying, can you tell me key concept about generative AI? And this is the answer that it came up with. So I don't know if it is true or not, but yeah, this is just based on that particular PDF and the English language embeddings that are given from OpenAI, right? And I do see like sometime back on our Telegram channel, there was a question: can we build a RAG system using these vector databases? And my answer was yes. And this is like another example that that basically you can create a RAG system which you can use for like fine-tuning your LLMs, can be built using the vector databases.
Sorry, a rack system?
So retrieval augmented generation, what these are is like you can train your LLM basically using these rack systems. You can feed them different data, and they'll try to create their own embeddings for that particular data.
Is that, I'm scared to even ask this, but is that related to LoRa's?
No, not specifically. So
Okay.
LoRa's are an approach to fine-tuning a model.
Okay.
And then RAG is different, because RAG is almost like you give it a long-term memory through one of these vector databases. And the fact that the database has this linguistic layer allows the LLM to actually find stuff in it. So as an example, we created a RAG system for our friend John's medical records. He is a chronic illness patient who has been seeing doctor after doctor after doctor for 8 years, getting lots of testing done. He has a 4 terabyte solid state hard drive he has to bring around to all his doctor's appointments. And then he has enormous trouble just getting like the right information together for like an insurance request. So with a RAG system, you could feed it the embeddings generated from his medical records and then say, show me every genetic sequencing test that's been done, and then it would find him, list them. That's a RAG system.
Right.
LoRa is fine-tuning the intelligence of the model, which is like a different way to change the way the model performs. And actually, for state-of-the-art stuff, people are doing both. So it's kind of fun.
Right.
A lot of companies use it for their.
Microphone, my friend.
A lot of companies use it for their own internal policies. So they can put all their policies in one thing and then have somebody go through and ask, okay, well, how do we do this particular thing? And, have it all sitting right there for them.
Yeah, at my company, I built a rack system basically to understand where our tests were failing so that we could automate our testing capabilities. So that like every time a test fail, it goes through the rack systems and say, hey, have I ever encountered this particular error? And then if it is there, it knows how to solve that. So we are also using something called as DOP to basically train our rack system to give like specific answers, because sometimes you get a 500 error and it could be a bad server or the Kubernetes part got down, and that's why you got an error. But it will try to change the code, which is a false positive at that point. I do have a question. Yeah.
Yeah, hopefully not going too much back to basics, but the embeddings, is that what the vector database stores? So like
Yes.
you know how like ultimately like for SQL, you're gonna be storing some sort of like floats and strings and stuff like that. I'm
Yeah.
storing embeddings that are generated through these systems, and then that was then retrieved. And then the vector database job is to maybe do some of these algorithms to find nearest things where you query off of. Am I understanding that where the functions and authority is lined with this?
Yes. So in the vector database, and that's the beauty of it, right? Now, suppose you create a traditional database, a document store, which stores like all your images. Now, that data would get exploded. It would go into petabytes if you start storing like each image with its metadata, right? But now, if you are storing just some mathematical pointers, coordinates in space, that requires like maybe a byte of data. And now you can store like, I don't know, 16 million images that way. So basically, you are just storing the coordinates in the 3D space or n-dimensional space.
Got it. So the struggle is the compute side, because you got to basically determine those derivatives and those context of the data itself. So like if you store, let's say, 10,000 images of a dog, it's completely intensive to figure out what those like meta things are. But once it's there, it's very small, and you can store it into a
Yes.
database. Got it. So it's very compute heavy for the gain of very storage light and retrieval light.
Right.
Cool. Makes sense. Thank you.
Another question?
Yeah, I was wanted to clarify the distinction between RAG and fine tuning. Again, I wanted a little bit more clarity on that. So, is with a RAG system, you're adding embeddings to the existing embedding database? Is that true, or is that something else? Or and then with fine tuning, are you just updating how the query responds to the existing embedding? So I'm just curious on the distinction between a RAG and
Fine tuning.
Fine tuning,
Okay.
yeah.
As Stanley explained, fine tuning is mostly like changing how the embedding would be generated by the LLM itself, right? So you are adding more context to it, like in a heavy way or a 50,000 foot.
So you're recreating the embeddings.
Yes, you are recreating the
Okay.
embeddings. Whereas in a RAG, you are adding to the existing embedding. Say, suppose now you have embedding for English text, right?
Yeah.
But you want to make your LLM very specific to, I don't know, for lawyers, right? Now, now you will need to add all that legal information, the legal language, semantics to your embeddings, and then at that time using a RAG sort of system helps.
So if you're building a RAG on top of, like, say, OpenAI, you're taking their existing embeddings, and then you're taking your knowledge corpus, and you're replacing some of the embeddings and the existing embeddings with the RAG, or you're just adding a whole new set of embeddings?
I would say it's more better to be additive at that point of
Yeah.
time, because if you are creating, so basically the whole point comes out to be, say suppose you use GPT as is, right?
Yeah.
If it doesn't understand your specialty, if it
Right.
doesn't understand your context as a lawyer, for example, then it will give you like a hallucinated answer
Right.
altogether. So if you want a specific answer which is factual based on the documents that you have given, then RAG systems are really good at it.
Right, right. And they basically just added embeddings, right?
Yeah.
Yeah. So, no, go ahead.
You referring to the low rank adaptation, apparently we can combine that with other types of fine tuning. When do you personally and professionally decide if you're going to use high rank adaptation or any other sorts of fine tuning based on, circumstantial, whatever it is you're working on,
Forgive me, this is one of my favorite questions right now, y'all. And no perfect answer yet. We're still understanding what you can do with different fine-tuning methods and different approaches to constructing data sets. And we're finding out that there's more and more you can do. We're getting more and more surprised at how much you can teach these things if you do it right. LoRa is really interesting. So as Gaurav said, RAG is essentially taking an existing LLM and giving it like a memory, like a longer-term memory. It can access this RAG system, pull up information based on what it's looking for. Fine-tuning is like you're actually like scrambling the neurons. Well, hopefully not scrambling, but you're actually going into the neurons that store the intelligence of the LLM and kind of restarting the training and tweaking them a little bit. But to do the full training, we remember that these things take 10,000 GPUs working for 9 months. So you can't actually retune the entire network that contains potentially billions of parameters. You pick a subset of parameters to tune. And yeah, there's quite a bit of complexity into what performance with what data you can get out of tuning how many parameters. LoRa is really interesting though, and the punchline of what I'm saying is start with LoRa, and if LoRa works, that's great, because it's so much easier than any other method. And then what LoRa does that's really special is it doesn't change existing neurons. It adds an extra layer or two just on the end of the network. So it's almost like giving an interpreter to your LLM that kind of takes the output and then reframes it without touching the core intelligence of the model.
Right. All right. Did everyone try doing the demo, or should we go to the next
It's
one?
on the collab notebook. Oh, shit, I haven't done it.
We can jump to the next one. We can play with that more later.
Yeah.
I was trying to get on my phone, but it doesn't seem to work. Or at least I didn't get that far yet.
I'll put the second one, and I'll show it to everyone on the screen as well. With this one, this is the adopted demo by Single Store. Single Store is just another vector database provider, like Pinecone or QDOT or any of those. And what they tried to do is they tried to use this FaceNet neural network, and they were able to build their single store database with like 16 million images records. And today, as part of this demo, what I did is basically I used their database, and since I don't want to spend more money, so I just used 7,000 of them. And let me go down. And again, over here, I have given specific instructions for everyone to um, to create like an account on single store and how to use um, their secret key basically. So you should take it from the connection URL, and from there you need to copy the JWT token. Here's mine, and it would be expired by now. So that's what you get, right? So I did a dot product. So as I said, that we'll be using SQL, and just to help us with vector databases calculation, single store has actually created a function that takes the dot product of the vectors for you. So that's what we would be using. And as you had asked, like, how do we use SQL? Because SQL gives you not but you can have like a specific value to be found, right? So a similar thing we would be doing over here. As you can see, I was looking for Adam Sandler, and I was looking for the image number 003, and the vector value I got was 1. So that's a perfect match. But not only that, it also found some other points which are close to it, and this is the probability that you can see for those vectors. And
Ian Thorpe, what was that part?
Yeah,
kind of borked out on that one, huh?
Yeah, and over here,
It's interesting.
as you can see, I tried to search for Alec Baldwin, but I got Daniel Comiso as well, and Vladimir Mekiar. Yeah, so
I mean, they do look kind of similar. It's kind of interesting.
they do look similar, and yeah, I want you guys to try this out. And there is a list of again, I don't know. I need to get connected. Maybe.
But is it just looking by the file name, or is it?
Yeah, it's.
Oh, but then once it finds that, then it says,
then-
okay,
then
what
it-
else relates to this? And then those other pictures
Exactly.
do kind of actually look like him. Wow.
Exactly.
That's impressive.
That's what it is doing.
That's very interesting.
And
You know, going back to how Stanley was saying, how that's how we think too. You know, when you say something, oh yeah, that person looks like so and so.
exactly.
It's so interesting. I'm having such a blast with this talk, and want to just make a note that I'd love to come back after to adversarial training.
network,
I don't know if you guys have seen this, but so like someone actually so it's like I'll save it for the end, but actually someone hacked the brain's computer vision mechanism using this technology, and they can do something that's like borderline mind control.
Yeah, it's again, that's coming back to the point I said. This is again probabilistic, right? It's not based on number theory. It's more on the probability. So it is trying to find the probability, like these are the features that match this particular picture, and underlining this particular demo, we are using an open source neural network called FaceNet, which converts these pictures into some facial features, and we store vector embeddings of those facial features. So yeah, I would love if someone wants to try and go through it, and maybe we can also showcase their favorite celebrity. Let me see.
So you just added the name in there, and that'll do that.
No,
Like-
actually here is the drop down, and
Okay.
on the drop down you can find like those celebrities that we have inserted in the database.
Oh, you've already selected them in there.
Yeah, I've already selected Alec Baldwin over here.
But can we change it to Obama?
I don't know. Let me try.
Give me Obama. He's better than Baldwin.
Baldwin's facing trial.
That whole thing is such a cluster.
There was some other celebrity got hit with something yesterday. I got some
Baldwin,
email.
right?
Was it him yesterday?
Yeah, it was him yesterday. Yeah.
Manslaughter?
I don't think he'll get it, but I don't think. She Baldwin, yes. Free all the Baldwins.
Hey, is there any chance anyone could send me the Colab link on Discord? I just don't have Telegram on my computer. It's no problem though. I'll if anyone has it.
I'll send it to you.
Sir?
Why don't you get Telegram on there?
He's on Telegram.
Well, it takes like 30 seconds.
You know, I should. This computer is just my one little lake of sanity in my life, and so I just have an aversion to putting too much on it. But you're right, especially for the importance of this, I need Telegram.
Yeah, you can mute it too.
Yeah. Oh, thank you, Gaurav. This notebook looks amazing, and I'm gonna run it.
Sure.
All right, do we kind of cover most of the stuff there? Now we'll just kind of break off and everyone try it?
Yeah, we can try that.
Cool.
Actually, I was trying to change the
Oh, you're
capability
doing
for
it?
you.
Well, while you do that, I'll do our couple closeout messages because for anyone who doesn't know, we are here every Sunday, so we'll be back next Sunday. Sounds like Stanley's going to teach us about mind control next Sunday.
It's kind of interesting. Anyone see Began's shoes today?
Not yet. No,
Began is rocking the coolest kicks I've seen in several months, and they look like something interesting. They look like what's called an adversarial computer vision patch.
Ooh.
So it's like there's these little patches you can get. It looks like a little circle. It's like a sticker, and it has kind of like random looking static on it. And if you have a computer vision system pointed at you that's like actively saying like, oh, that's a human, I'm seeing a human, you put this sticker on and it thinks you're a dog. And so basically the pixels in this sticker have been designed by a different AI to glitch out the first AI. And then the way it does it is it sort of like measures it against the kind of system that Gaurav's showing. So it kind of goes like, oh, does this look close to this person? If it does, I'm going to change some pixels and then see how it does. And then that system of changing the pixels can actually like make it so that a human couldn't even tell the difference between the two images, but the computer couldn't classify it at all.
Very interesting. Did it work?
Yeah, I'm just putting.
You got me, Obama?
I don't know if I have Obama over there, but I'll give you like the list of 7,000 celebrities to choose from.
I'll add the survey.
Or not just
All right, well, I think we'll close this out for now. We can keep on tinkering. Well, thank you, everyone, for your attention.
But I'm not done with my talk yet.
Oh, you're not done? There's more?
Yeah, we have to go through some algorithms and also compare them.
Oh, we're already 6 minutes late, my friend.
All right. Let me just go it through pretty quickly while we are looking at this.
I think too that this is a talk that needs a sequel.
Yeah, I was gonna say maybe should we break here, and you want to continue this next week? I'm cool with continuing this next week.
Sure.
Okay.
Gaurav, if you were interested, I would even be so happy to kind of
That sounds great.
add a little to the mix, and then
Sure.
maybe continue because this actually feeds like so well into this adversarial example.
Sure.
That I think could be really fun.
Cool.
Oh my gosh, I had like no idea we were going to be talking databases today. This makes my Sunday.
I love databases. I started with Access databases, Microsoft Access databases.
Yeah, we did dabble into that.
I used to store images in Access databases. So if you wanted to access my images, you had to go through my security protocols.
So if anyone is interested in learning SQL, I just posted to Hack Sunday 4 SQL games, including a murder mystery game. This is an excellent way to learn SQL, and absolutely ChatGPT and Bard can help you here. SQL is more powerful than ever, and if you know a bit about its history, it was developed by the CIA as a secret tool to access the world's information. This is real. Larry Ellison is ex-CIA, and he adopted SQL and built a billion-dollar company. So he's one of the richest men in the entire world off of CIA technology. And SQL right now, Oracle is shit. Postgres is amazing. Don't use Larry Ellison's product. I'm not endorsing him. Where was I going with that? Oh yeah, learn SQL games. Yeah, it's powerful, and it's only getting better.
Awesome. Thank you much.
It's it's really incredible how like SQL is just one of the core technologies of the whole internet revolution. It's maybe changed our lives more than anything else, except for
Right.
electricity or fire.
Oh yeah, right up there.
Yeah, let's
All right.
break off now.
We'll break
and,
for next week.
and we'll do a part 2.
Maybe next week we'll even live stream it.
One more question.
All right, one more.
Sorry.
Sure.
Just out of curiosity, prior to all this vector databases, how did they train stuff prior? I'm kind of curious on what the context on why this was the natural solution that people decided to go to. Because like in a traditional machine learning model, I'm just storing weights, which could just be in a traditional SQL database, and you can fetch and then run your model off of. So I'm kind of curious on where did vector databases start to become like the necessary technology to continue with machine learning?
So, as far as I know, vector databases started to pop up when people started thinking in terms of like context, right? Where you have to search certain data for certain context. And that's where people started thinking, oh, instead of saving like the whole data and then querying the complete database, why can't we imagine as Stanley said, like a globe of words, and then try to cluster them. Also, it comes from a very important algorithm that is used in neural networks. It's called k-means clustering, and k-means clustering has been there for, I think so, since 1970s as a classifier. So it's not new. It's a different vision of the same old technology that we are now applying.
If I were to add one more thing to that, prior to having a formal database, if you were to look on GitHub to solve these problems, you would find individual libraries that provided this tool. So for example, there are plenty of k-means libraries. There are also tree structures that were being used to do vector-based lookups. So there's a trie. So that is a particular type of tree that is very useful in using p-hashes to do reverse image lookup. So if you were, for example, to look up how do you do a reverse image lookup or how do you do SoundHound, people were writing blog posts and they were using these data structures in memory. So that is basically prior to a database, that's what you use. You use a more primitive data structure. A database, what this does is it allows us to be reusable, to be packageable, to be, to have this amazing power at your fingertips without necessarily understanding how it's being done under the hood.
On that note, actually,
I was gonna say, I got tons of questions.
we do have certain data structures that I wanted to go over with. So here's
Should we hold that for next week?
yeah, sure.
You know,
Let's hold
and
it next week.
so it's actually for me just so exciting that this first part of this talk happened today. I do a lot of work with marine science and particularly understanding genomic data about the oceans. And just last week, a scientist I work with released the biggest data set ever of marine genomes with all of the integrated information about their environmental situations.
Right.
So I would love to maybe touch base over this week, and then if it works for next week, we could present some examples too. And I
Sure.
feel like digging into this would be so much fun further.
Yeah.
Sounds good.
Awesome.
Awesome. How about a hand?
Thank you.
Thank you so much, my friend.
Thank you, Gary.
You know the one thing I always do at the end of my talks? I do a little selfie.
Yeah. Oh, Jerry, that's a beautiful practice, bro.
Selfies?
Oh, this is so beautiful. Sorry.
Jerry, you gonna start a TikTok?